So as Wenke says, once upon a time I was a Linux security guy. And in 2010 I was invited to give a talk very much like this one on Windows 7 security from a Unix perspective. So I had this unique perspective of having done both. And in that talk I basically compared the security features of Windows and various NIX systems and showed that Windows had matched or surpassed the security techniques that the community had developed. And so you could say that Windows 7 was just fine for a prudent user to go access the internet. But for non-technical users, your family, you have to tell them to be careful what they click on. You get this advice all the time. Be careful what you click on. You know, you might get an email with some nasty links in it, but that started to create problems. The attackers got better. They noticed that software exploitation had become difficult, and so they resort to social engineering to coerce you into clicking on something. Worse, users got more demanding, that they wanted appliances that they just can use without thinking about it, and so it's no longer acceptable or effective to tell users to be careful. That just doesn't work anymore. And so this talk is about how Windows 8 raises the bar on this and a whole bunch of other problems. There's our agenda. We're going to start with the TCB and move up through the stack. So first, you got to seize the high ground. Way down at the bottom, UEFI is sort of the next step in evolution of BIOS, but it's a big step, so they gave it a new name. It's not a Microsoft thing. It's a industry consortia standards thing that Microsoft participates in. Some key functional benefits are that it's no longer just Intel chips only. It works with, it's architecture independent, so you can use UEFI on ARM systems. Its key security benefit is that it enables secure boot, which we'll go into. And it's a requirement to be a OEM hardware certified Windows 8 PC. So the old system, the BIOS, would just go and boot whatever you told it to. So if an attacker can get administrative control over a PC in any operating system, they just replace the master boot record and the BIOS goes, well, I guess this thing is what I should boot. Never mind what it is. With UEFI, now the firmware can enforce that it will only boot stuff that is signed by a certificate that the UEFI firmware trusts. So now the attacker can't just blanket go replace the operating system with whatever nasty malware they want. So what UEFI is enforcing is that the firmware, the drivers, and the loaders all have to be trusted, i.e. signed by the right certificate. The UEFI database lists the trusted keys so that it knows what it is it should trust. It supports a secure rollback feature, so users can say, no, I didn't like that hardware update, it made my mousey not work, but it won't let you roll back past a security update. It's got some remediation features in it so that it can heal itself if it has a problem. And UEFI is now updated with Windows Update. Windows Update has this very robust infrastructure for distributing updates to everybody, you know, the second Tuesday thing. So now we can roll out UEFI updates in a secure way to the machines. Sort of adjacent to UEFI is the Tpm chip, which you can think of as being kind of like a smart card embedded in your PC. It's a great place to store secrets buried so deep that even the operating system can't get them. So if your PC gets hacked, your private keys aren't disclosed. But it provides services, so your operating system can use those certificates to authenticate to various services that want to know that you is you. The TCG standard, we call it TPM 2.0. TCG calls it TCG TPM Next. Windows 8 TPM support. support for both discrete TPMs and firmware TPMs, which is TPM functionality without the physical security. So it's not as tamper resistant as TPM normally is. And this is a logo requirement for Windows 8 PCs that want to be what's called Instant Go qualified. And that means that it's always on, always connected, and fetching mail even while it's asleep, kind of the way your phone does. So having built in all that secure hardware, we can now get to the good stuff, where you can actually do a secure boot. Trusted boot means only boot signed operating systems. This provides you end-to-end protection that the thing you're actually booting is the operating system you intended. For us, it's Windows. For other vendors, it can be any operating system. We didn't lock it into just Windows. It ensures and prevents compromised OS's booting. It prevents software from starting before your antivirus, because then it could disable the antivirus. That's a program called ELAM, early launch something. Early launch anti-malware, so that the malware can get in there first and take control before the malware tries to. Measured boot, related, is attesting remotely that you have in fact booted a trusted operating system, because it's very nice that you know you booted a clean OS. How does that server over there, like your bank, know that you booted a clean OS? So here's the trusted boot process in comparison. Before UEFI, current generation, the BIOS would boot whatever malware and then load whatever drivers, more malware. So you don't really know what you're booting. And now, UEFI ensures that your, where's the mouse? There it is. That you're booting a trusted operating system loader, a trusted anti-malware product, trusted third-party developers, gets you all the way to Windows Logon. That stuff is not malware. It's in fact the intended operating system. Measured boot, the old thing, would measure the BIOS, measure the master boot record, measure the OS loader, and then the kernel starts up, and it's whatever kernel. Okay, we still don't know what operating system we're running. Windows 8 measures the kernel, the drivers, and the anti-malware software. So that you can have a remote server can have much more trust in what you're running. So here's the animation of how it all works. You boot up. The secure boot prevents malware from loading your OS. The anti-malware software is loaded before anything else so that the antivirus stuff is working. A measurement of all this stuff happens in the TPM, and so now we know that we're building the right thing. Now your client goes and attempts to access some server, and the server says, I only talk to healthy PCs. Cough up your certificate. Okay. So it goes back to the TPM and retrieves the signed measurement of what you booted, hands that to a remote attestation service that says, yep, you booted a good thing, and hands that back to the service you were trying to access that goes, okay, you're running on a real operating system that we trust. Now, who are you? So moving further up the stack, protecting sensitive data. Encryption, drive encryption, we are trying to make it go mainstream. Traditionally, it's only on enterprise machines where people get really hypertense about stolen data because of SB 1386. Oh my God, 50,000 customer records were stolen and now it's in the Wall Street Journal. Well, that's tragic for that corporation, but when your Facebook password gets stolen, bad things happen to you. So you want it to be pervasive. It's good to have your devices encrypted pervasively, but there are problems because TPM isn't pervasive. The trick to drive encryption is where do you put the key? So we turned device encryption on by default. In these things, And we can do that because they're almost all connected to their Microsoft account, your cloud account. And we do that, we put the drive recovery key into your SkyDrive. So when something happens and you need to get your box back, it goes through this dance with you and your cell phone and your SkyDrive account to get you your recovery key back so that it will unlock your drive. That allows you to have pervasive encryption on consumer devices, because if, oh so sad, you lost your password, we won't let you have your data back, is not acceptable to consumers. So you need to have a reliable place to put your drive key that is also secure enough to protect the device. So drive key in the SkyDrive is good enough for, oops, I left this in a taxi, because the guy who steals it out of the taxi doesn't know what account I have. He doesn't have access to that account, so he can't recover the data. All he can do is take the device. Classic enterprise encryption, on the other hand, oh, now we're talking about really valuable data, and the victim, vice president of R&D, might be subject to a spear phishing attack where a professional thief is following him around, watching him chat up people at a conference, and when he turns his back for a moment, nicks the PC. Meanwhile, he's already, if the key was already in SkyDrive, they might have already compromised his SkyDrive account too, and then they can get the plans for the next Boeing airplane or whatever. But by putting the drive key in AD instead of in SkyDrive, now it's under enterprise control, so that attack doesn't work. So putting the key into SkyDrive, good for consumers. Putting the key into your enterprise asset management, good for enterprises. This is what I worked on, is making it safe to click. First, I want to explain this notion of user confidence. What's the security boundary that we're trying to protect? We want end users to have the experience that they are confident in their PC, that they can try and buy and discard as many Windows Store apps as they want. And if you don't like what the app is doing to you, you uninstall it and you get your PC back. It doesn't prevent everything, like it doesn't prevent denial of service. If an app uses up all your disk space, uninstall it and you get your disk space back. If it's hogging your CPU, don't run it. So within reasonable bounds, you uninstall it, you get your PC back. The typical user should never have had a bad thing happen to them personally. They should not have any friends who've had bad things happen to them either. They might have read about something bad that happened in the newspaper somewhere. So it's not that it never happens, it's just that it should happen rarely. And we achieve this through the App Store onboarding. We actually curate the apps looking for malware and vulnerabilities and craziness. And we have a kill bit so that if an app is discovered to be malicious, we can kill it worldwide on everybody's PC everywhere within about a day. So even if malware makes it into the store, if it does anything obviously malicious, it doesn't live long. And with the Windows 8 app container, that's what I actually worked on. So what app container does, in addition to the app onboarding process, is that the apps are sandboxed. So they're restricted, they don't have the full authority of the user, they don't get to mess with the operating system, and they get some controlled access to other apps, which we'll show. So it is secure by default. That's a fundamental security property that the professors in here at least will recognize, that if you want a sound security barrier, it has to be secure by default. And what we did there is we changed the kernel, that it says, are you an app container? Oh, well, then the answer to your access request is no, unless there's some marks on the ACL that say, yes, we should allow access to app containers. So this allowed us to have a confident conviction that the Windows operating system is not going to be tamperable by app containers, except for the parts where we turned it on and said, okay, yeah, you get that, and that, and that. The app only really has full access to its own app folder, keeping it isolated from other apps. It gets access to files, like users want to use apps on their files, right? So you need to give the app access to any file, but not every file. And you want it to be under user control. So the way it works is the app says, hey, I need a file. The system says, oh, just a second, I'll be right back. I'm going to go ask the user about that. The file picker comes up, and the user drives the file picker to select a file, hits OK or cancel. Why would Angry Birds be asking for files? And so when the user says OK, then the system returns a file handle to the app. So here's my demo. Hey, Keen, this USENIX thing, what? And you can't see any of that. So this is a modern app notepad taker. So what you see here is not the app. That's the system file picker. So now I can go save my thing here. So the app got to save a file into my user folder without actually having access to the user folders. What are you doing to me? There we go. So some interesting properties here. That there was no app access to files granted unless the user said so. There was also no mother may I, should I just do the thing you told me to do, consent prompt that annoys users a lot. We hid that inside the choose dialog of not, oh, should I go access the file that you just told the app to access? It's, which file would you like to grant to this app? There you go. We call this an authentic user gesture because only the user can do it. The app cannot. An AUG is useful in any scenario where you want the user to have control over something in this privileged domain that the semi-trusted entity over in that privileged domain shouldn't have. And we use this widely in Windows 8 to allow users to use their apps to do anything, but not allow the apps to do everything. Similarly, share. There's share contracts in Windows. Will it let me do that? So, chocolate. Clearly something my wife needs to know about. So I click share, mail, and that there is an AUG. The app doesn't have access to my mailer. The app just said, I have something to share. I click the share button and the system lets me choose what app I want to share it with, and I'm sharing it with my wife. And it sends it, and the app had nothing to do with it. So again, the share charm is another AUG. This lets apps arbitrarily share stuff with any other app you want, but not under app control. It's under user control. So that's why I describe this as being like pipes for real users. You don't have to understand geometry and Unix command lines to take apps and compose them together. We want it to be safe to browse. Clicking should not be dangerous. So we added the Smart Screen phishing filter. This came in Windows 7 IE 8, and what they were looking for was phishing sites. They're short-lived, they pop up quickly, so you need a very rapid mechanism to propagate that this is a dangerous website, because it's probably going to live for about 12 hours. It has about 500 million customers, 14 billion requests a day, because what it's doing is every time IE visits any URL, as long as you've opted into this program, it transmits the URL to Microsoft servers that go, yep, that one's not on the bad list. So it's going to get a lot of traffic. And so far has issued something like 200 million phishing warnings since inception. IE10 added enhanced protection mode. This is, IE7 was the first browser to come with a browsing sandbox, where the web page that you see is running in a lower privilege process than the entire browser that has all the Chrome and the buttons and the stuff. That was built on top of Vista's low IL feature. So sandboxing stuff going back to 2006. IE10 upped the ante. The EPM, Enhanced Protection Mode, is that same sort of browser sandboxing thing, but this time built on top of App Container. So in the modern browser, the one in the new UX, EPM is on by default. And in IE11, coming in Windows 8.1, EPM is on by default everywhere. So even on the classic desktop, you get the stronger sandbox. And you want it to be safe to download. So Smart Screen got smarter. IE9 on Windows 7 added a download reputation checker, where if you download something, IE would checksum it and send that up to the cloud and see whether it's malware or not. And Windows 8 and IE10 added that checking to the shell, so that if you download stuff any which way, that you get the Smart Screen protection. And any which way has a little caveat that whatever app you use to download the thing has to call a feature called AES, Attachment Execution Service. Yeah, we picked the name before the crypto standard came along. And it puts cooties on the file called mark of the web. And the shell knows that when the mark of the web is on a file, hey, that's kind of suspicious, we should do something about that. And with respect to Smart Screen, what it does is checksum it and send it back up to the cloud and say, is this okay? And of course it uses caching. It doesn't always send it back up to the cloud. It sends it up to the cloud if the cache doesn't have it. And so in this way, even if your mom got trolled by one of those fake AV websites that says, oh my God, you're so infected, only $29.95 to clean your PC, here, pay up. That the Smart Screen thing will stop that and keep your mom out of trouble. They issue about 2 million malware warnings a day, 2 billion warnings since inception. So hardening apps against exploitation, all that stuff was just making sure that an ill-behaved app, whether it's malware or infected or whatever, doesn't hurt you too bad. This is about keeping good apps from going bad. There's this broad long-term trend that attackers are moving from attacking the operating system to attacking applications, because it's easier and because that's where the money is. Therefore, it's incumbent on the platform to help the app stay safe from the app's own bugs. In 2002, Windows, surprisingly, was the first to deploy stack canaries in a widespread way. My little company was shipping a Linux OS that had canaries throughout, but that was a teeny little minority distro, and it was about 3, 4, 5 years later that major Linux distros caught up with that. So Windows was first with protecting apps against stack overflows. Windows was first with ASLR and DEP, not first in the universe, but first in the commodity operating system space. And Windows 8 has added heap randomization, so make the heap jiggle to make it hard to hit with your memory corruption attacks, and high entropy ASLR, so that it's really hard to hit those randomized things. That's only on 64-bit because you need the address space to make the things move in wide ways. And all these defenses are on by default in the store. They were all previously opt-in, so you had to go and convince software vendors to opt into these enhanced protections on Windows. In the store, because it's a new platform, there was no app-compat legacy to live up to. So we just turned them on by default. And if your app isn't compatible with that, then, well, gosh, it's not going to work in the Windows 8 App Store market, is it? So just leave those things turned on. We turned them on for you anyway in the IDE, so you have to work at it to turn them off. So as a result, a Windows Store app is unlikely to be malicious because of the onboarding and the kill bit. It's unlikely to be able to do anything malicious to you because of the app container and the authentic user gestures. And now it's unlikely to even be exploitable because all of these protections are turned on. And so users have good reason to be confident that they can just use stuff in the modern environment and it won't hurt them. And finally, modernized access control. It's the fifth immutable law of security that weak passwords trump strong security. Last year, Matt Honan had this lovely article in Wired about how he had a cascading string of failures with someone pwning his passwords in various social accounts, taking one after another. And he lost all his pictures and all his data, and it was terrible. And his thesis is, passwords suck. He's right, they do. There's therefore a need to have something stronger than passwords. And if you're an enterprise with lots of money, you can use fancy smart card tokens. But now Windows has support for what we call virtual smart cards, which basically turn your PC into your smart card. So you have to have the PIN code for the virtual smart card and this PC, not that PC, not that PC, this one, effectively turning the PC into 2FA. We have new sign-in options for touch machines that make it easier to use. And this table here is showing the amount of entropy in PIN codes, passwords, and picture passwords. And okay, you can complain about the entropy of PIN codes, but it also has a lockout feature that you only get a small handful of tries before the machine locks you out. The key here is that password cracking doesn't work if you don't have an offline attack against the passwords. If your only way to try passwords is with your fingers on this PC and it's implementing a lockout policy on you, then cracking is going to fail. So here's my stunt. There, the machine's locked. Oops. Come on. Well, that's not going to work. The screen resolution isn't big enough. So that was me logging in with a PIN code. And the point is that I don't care if you shoulder surf me, because you'd have to steal this PC, because the picture password and the PIN code aren't roamed to other PCs. They're only on this one. Again, that makes the PC effectively 2FA. So biometrics. You may have seen in high-end business-oriented PCs the fingerprint readers, and they're kind of flaky, and they're not universal, and well, would be nice if you could just open the machine by thumping it with your thumb. And that's the opportunity that's coming. That fingerprint reader adoption is going up fast among hardware vendors, and our goal in Windows 8.1 is to make this available everywhere. The technology choices are getting richer. The readers are getting smarter. The old ones were just like a photocopier. They were looking for ridges they could see, and the new ones use a combination of thermals and ultrasound and capacitive touch. They allow you to authenticate by just placing your finger onto the pad instead of having to swipe it at just the right rate. There was this incident, well, never mind. So they need to be easy to touch, no agility required. That's the thumbprint gizmo that I was looking for. So you don't have to swipe it, you can just lay your finger on it. And you want this to be available in apps. It should be a common experience in PC settings. You want it to, so suppose an app wanted to support in-app purchase. So you have a PC with like a cool casual game, and you give the thing to your kid to play with, and the kid, next thing you know, has turned around and bought $1,000 worth of artifacts in the game because they don't know what they're doing. In-app purchase would force you to re-authenticate to say, no, I really meant to purchase that. And this biometrics support plumbs the biometrics APIs from not just when log on, but now makes it available to apps. And that's actually an authentic user gesture because it doesn't result in coughing up the password to the app. It results in Windows authenticating to the cloud that you are in fact you, and then connecting the app back into the loop. So this protects you in scenarios where it's primarily a single user machine, like this is my PC, the kid doesn't have an account on it, but maybe he wants to play a game, so it allows me to confidently hand the machine over to the kid without getting a huge bill for crazy online purchases. So, concluding, you can give a Windows 8 PC to your family with some confidence that Windows will help defend itself against Trojan horse attacks and socially engineered attacks. The Smart Screen Defender will prevent your family from obliviously loading malware that some website told them was a really good idea. And the Windows Store apps are that plus curation. So they're very unlikely to be malicious because they were onboarded. They're even less likely to be malicious because we'll kill-bit them as soon as they do something. The restricted environment of the app container makes it very difficult for malicious apps to do anything interesting to you without your interaction. And therefore they resort to social engineering. And the thing with social engineering attacks is you can see them. So they get reported to the store, so they get kill-bitted, so they don't live very long, so the odds of it happening to you, very, very low. They might happen to somebody, someone in the planet, someone in the room got the malicious app one day, then it happened a few times, then they complained about it, then it was killed. No endemic. Windows RT, in addition, drive encryption on by default. So I can leave this in a taxi without, I'm annoyed I lost my lovely Surface, but I didn't lose my identity and my passwords. You can give it to your staff with confidence. You get the same protection as with consumers against all of that, oops, I shouldn't have done that stuff. And enterprises can create a secure and manageable environment with enhanced access controls and device health attestation, and so forth, these nice enterprise features. And the Windows Business products support the same device encryption, but with the keys stored under enterprise management instead of just shoved into your personal cloud. And you might actually want one too. Never mind giving it to those other clueless people. You could use one, because I bet that you visited a dubious website, you downloaded an exe that you're not real sure about, or you left a device full of passwords in a taxi. Thank you. Questions?
So thank you for the talk. So basically, a lot of the security posture comes from giving control to Microsoft, which everyone can decide to do or not. My question is, why on earth did you give the control of the signing keys for EFI to Symantec of all people? Like I cannot get a signing certificate for booting something else on a secure boot Windows machine from Microsoft. I actually have to go to Symantec.
Because we didn't want to be in the key business.
Okay.
There's an industry full of key business, and we gave it to the leading vendor. What we wanted to do was simultaneously provide the capability that we can have secure boot, that the system can boot all the way up and we can be sure that it was not some malware stuff, and have it open so that the Linux industry can also boot something up and have it be secure, that the hardware said, yep, this is really intended and it's not malware. And there's no way to do that without having some kind of CA in the loop. So we had to find a CA. There's a CA.
Hi, Yulia Yon with Google. Great talk, first of all. I think we are moving in the right direction. My question is, how long do you think it will be before I can stop telling my mother to be careful what links she clicks on and what apps she installs?
I think that we're there now if you give her Surface RT. If you give her a Windows 8 not RT, the classic Intel and AMD processors, then she can still go out into the classic environment and click on things. Smart Screen will say you probably shouldn't do that, but if your mother's determined, she can do it anyway. So there's somewhat less assurance there.
So is that the only platform I can give her that would today achieve such a safety on the web?
Well, it's a matter of degree.
Hi, Hadi Askari at Delft University. Thank you. Some of these features sound really exciting. Regarding the kill bit, as you called it, what is the possibility of this feature getting abused in, for instance, copyright fights, or for whatever reason, if an app needs to get wiped off all across the globe? So not the security thing you intended, but...
Well, Microsoft has absolute control over the kill bit, and we don't use it lightly because we don't like getting sued by software vendors. We only use the kill bit when we're sure that something is malware. If we have other issues with an application, we have softer measures than the kill bit.
Right, I understand Microsoft's motive here, but I mean, if you have that feature there, it's possible for someone else to sue Microsoft to do that, or force Microsoft to do that. I mean, the capability is there, so...
All the app platforms have that feature.
Okay.
Hey, Crispin, a little follow-up on that. Another Killbit related question. Slightly different, although what he asked was kind of my concern. But, and these two are related, but one is, does your Killbit destroy user data that may be generated from the app?
To define terms carefully, there's app state is in the app folder that is dedicated to that app. User data is stuff that the app had to export by going through that file broker I showed you. So if some app, I'm not going to name that one because it's not malware, but if some app were malicious, then all of its app state, its settings would be removed from the PC, but the files that it had exported would not.
Okay. I'm thinking in particular, it was the case with Amazon that pulled an ebook over a copyright dispute. I think it was something they had published without securing the copyright properly.
Yeah,
And
I remember
there
the
was
incident.
a kid that had annotations for his book report get destroyed in the process. Right.
So I can't predict what would have happened legally in that scenario, but at a technical level, if the app in question, the kid had said save as and exported the document out into his document folder where there was a PDF with his annotations, then that would not have been removed. If he had just left the book in the app state, then it would have been removed.
So there are cases where the data in a sense, generated by the user could be stored with the app and then lost when it's killed.
Yes, it
Okay.
depends what the app does.
Okay, okay. And then the other thing is with the kill bit. Is the kill bit mandatory, or can a user opt out or defer removal?
If you opt out of Woo, then the kill bit becomes discretionary, but so does getting apps.
Okay, does that mean
They come
if
through
you
the same
choose-
channel.
If you choose to get the app,
If you choose to get any apps,
you choose to accept the kill bit.
installing apps comes through Woo, so do kill bits.
And that means if you issue a kill order, it happens whether or not the user wants it to.
Right.
Is that correct? Okay.
Yeah, we don't use it a lot.
No, that's fine. I'll tell you my reason for asking, right, is as I think you know, some people here don't know, I work in an observatory where, you know, if we're, cosmic events, you don't get do-overs for. Okay?
Yeah.
Right? We might be in the situation where it's like, okay, we understand this needs to get removed, but right now we don't want a thing to change on this system, and we'd be happy to do it after the event's over. Something like that.
So if you want your whole system locked down for fixed duration, yeah, turn off Woo. Conversely, you could either design or choose apps that don't store your stellar events in app state. They store it in a user folder.
Right. Well, you know, sometimes we don't get the choice of which apps get used, but
Well,
But-
as a technical matter, that's what will happen.
yeah. Okay. Thanks.
So, Crispin, so is it true that then for something like Surface RT, the only application that it can run is through the App Store?
The technical requirement is that the only programs that can run on RT are those that are signed by Microsoft. And all the stuff that goes through the App Store is signed by Microsoft. It's signed by the App Store. In addition, RT ships with a copy of Office that was signed by Microsoft that runs on the classic desktop.
So then it's not a machine suitable for students to develop their own program and test and do projects, right?
I'm not sure about that.
Well then, suppose I tell students to write C program and it's run on Windows.
You can unlock all this stuff by installing what we call a developer key. So you have to go through a few hoops to unlock the device so that, all right, it'll now let you do what you want so that you can do development on it.
Okay, thank you.
You mentioned in your presentation about the fact that you were able to.
Sorry, a little closer.
You mentioned that you were able to, with the new UEFI boot, everything was required to be signed prior to this. What controls, what protections are you putting against where the CA itself is compromised or the certificate itself? I mean, this has happened before. Okay, where according to, as I recall, within Stuxnet, that they actually were able to forge a certificate from a valid CA. And also with the fact that MIT recently had an article talking about how new developments from last week's in Black Hat, they were talking about new developments in mathematics, which saying that older crypto systems may actually be at risk for being compromisable. What protections does UEFI have for that? And say a certificate does get compromised, how does the device get that revocation?
There is a kill protocol in UEFI, so that I don't work on that feature, so I don't know what the granularity of the kill bit for UEFI is, whether it's individual packages or CAs or whatever. I do not know. but we can kill individual things that got compromised. I'm not aware of many systems in the universe that are resilient to suddenly discovering that factorability is polynomial. We do try to maintain crypto agility that we strongly recommend against people hard coding any cipher. You should just use, you know, a public key signature, and underneath the covers we'll use the best one. So if RSA is broken, I imagine there will be a lot of running around, and not just at Microsoft, as everyone flips over to whatever public key protocols are not broken.
Scott Carlin, Princeton University. Can you expand a little bit on the smart screen technology? It seems like that's a place where basically everybody's browser history in the world goes right to Microsoft, and there seems to be some, you know, privacy security implications.
You opt into it. You don't have to do it if you don't want to.
Okay.
And we don't look at it, we just reputation check it. Is that a phishing site? Is the checksum on that program known badware, or is it known goodware? Programs are also checked by publisher. So if it's a known software publisher's certificate and they shipped a new program, we don't start failing it just because it's new software. Everybody, please sign your programs if you're serious about distributing them.
Thank you.
Well, thank you very much.